Hello and welcome to the College Algebra sample final exam. Let's get started. We're going to go over several problems that could be on a final exam, similar in style, similar in content, different numbers. So let's get started with the first one. We're trying to simplify a rational expression with radicals. We want to obviously rationalize the denominator. In this case, we have a binomial in the denominator, so we need to multiply by the conjugate. Okay, so the conjugate of 3 minus 2 root 5 would be 3 plus 2 root 5. And we would do that for the top and the bottom. So when we go through and multiply this, the top and bottom, they're like a FOIL problem. Okay, so we'll multiply 3 times 3, give us 9. 3 times 2 root 5 would be 6 root 5. 2 root 5 times 3 would be 6 root 5. And then 2 root 5 times 2 root 5 would be 4 root 25. Yeah, now we'll change that root 25 in a second, but that's what we end up with in the numerator. So for denominator, same idea, except the denominator, because it's opposite signs, we'll just have like a squared minus b squared pattern. So we have 3 times 3 is 9 minus, right, negative times positive. 2 root 5 times 2 root 5 is 4 root 25. And again, we'll change that up in a second. Okay, simplifying this a little further, we have 9 plus 6 and 6, that's 12 root 5. Right, we just add the coefficients, keep the root, and then we have 4. Now the square root of 25 is just 5. Okay, so we just replace the square root of 25 with 5. Okay, now for a denominator, same idea. We have 9 minus 4, square root of 25 is 5. Okay, going a little further, 9 plus 12 root 5 plus 4 times 5 is 20. For our denominator, make the same replacement. So we have 9 minus 20. And then combine like terms in the numerator. So we have 29, right? 9 plus 20 is 29, plus 12 root 5. And then denominator, 9 minus 20 is negative 11. So we can have negative 11. Okay, and you can stop there. If you want to go further, you want to pull the negative to the middle, you can. If you want to distribute the negative to the top, you can. If you want to make them as separate fractions, you can do that as well. Okay, so if we do the separate fractions, it'll just be negative 29 over 11, and then positive divided by negative, that would make that a minus 12 root 5 over 11. Okay, so either way, you could have one version of these. All right, 2, quadratic formula. So remember your quadratic formula, x equals negative b plus or minus the square root b squared minus 4ac all over 2a. So in our formula, we're just going to isolate a, b, and c. Okay, and this is one of the formulas that will be given to you on your formula sheet. So don't worry about it. Just make sure you know how to use it. Just make sure your equation is set equal to 0. Okay, and once it's set equal to 0, now you can figure out, you have your A. A is the coefficient of x squared, is 2. B is the coefficient of x, which will be negative 7. And C is the constant, which is 4. Okay, so just plug these in. So you have negative b. So b is already -7. So negative of a negative is positive. Plus or minus square root -7 squared minus 4ac. And this will be all over 2a. So 2 times 2. Okay, and now we just simplify it. Okay, so we have 7 plus or minus square root 49 minus 4 times 2 is 8. 8 times 4 is 32. 2 times 2 is 4. 7 plus or minus the square root 49 minus 32 is 17. And this is all over 4. Now, obviously, we can go into further detail. Now, 17 doesn't break down, so it would stay as the root 17. If it does break down, make sure you break it down, and then you would look to, simplest radical form. And then if things can reduce, they would have to reduce all three areas with the number in front of the radical, the constant in front, and then the denominator. So you could reduce by all three numbers at once if it's available. All right, number 3, solve by factoring. Okay, so factoring here, this would look like a AC method. Right, we have A times C. 5 times -12 is -60. So initially we're looking for two numbers that multiply to give us -60, and they're going to add up to give us a -4. Okay, so let's go through the factors of 60, and then we'll figure out the sign later, positive and negative. We have 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10, 7 doesn't work, and that's it. Okay. All right, so it looks like it's going to be this last one, just a matter of which sign to place where. When I add them up, I have to get a -4. So a +6 and a -10 seems to do the trick. That'll give us a -4. Okay. All right, so remember the technique I show you guys in class. I have my 5x squared. I'm just going to take the 5x part. All right, two 5x's. The two numbers that we came up with, put them underneath. And then we're going to reduce where applicable, right? So 5x plus 6, 5 and the 6, we can't reduce. So that's one of our factors. The other factor we can reduce with the 5 and the 10. We could reduce by 5. So we have 1 and -2. So x minus 2. And now set each factor equal to 0. So we have 5x plus 6 equals 0. X minus 2 equals 0. And then you just solve for x. Right, minus the 6, so we have 5x equals -6, divide by 5. So this is one of our solutions, -6/5. And then add 2, so x equals 2. So there's our other solution. Okay, so -6/5 and +2. We are two solutions. Okay, simplify the radical. We're looking for perfect squares. Okay, within 75, you got to think in terms of quarters. You have 3 quarters, right? 3 times 25. So we can say 3 times 25. A to the 5th, you have 5 A's. B to the 4th, you have 4 B's. Okay, now think in terms of square root. So you have the square root of 25. What does that give us? Square root of 25 is 5. Okay, so that's done. Now every pair of our variables was going to come out as 1 because this is an a squared, right? Every pair, square root of a squared is a. Okay, so that's gone. Another pair here, that's another a. Okay, so far 2 a's on the outside. Single a is left, another pair of b's here, so 1b, and then one more pair of b's, so another b. Okay, what's left inside? We have a 3, and we have an a. Okay, put these together on the outside, we have 5 a squared b squared, and inside the radical we have 3a. Okay, so this is our final answer. All right, let's take a look at our next page. Okay, simplifying. So here we have a division. Remember, with division, we're going to do keep, change, flip. But at the same time, before we do anything further, we're going to also make sure um, to factor, right? In fact, let's simplify this. Um, let's just rewrite it with our keep, change, flip in mind. So the first one we keep the way it is. We're going to change division to multiplication, and then we're going to flip the second one upside down. So x squared plus 6x plus 5 will be on top, and then x squared minus 2x minus 3 will be on the bottom. Okay, next step, we're just going to factor. Okay, so for each of our quadratics, we're going to factor. What multiplies to 6 adds up to -5. That'll be -2 and -3. So x minus 2, x minus 3. For our denominator, what multiplies to 20 and adds up to 9? That would be 4 and 5. So x plus 4, x plus 5. For our numerator on the right, multiplies to 5 and adds up to 6. That would be 5 and 1. So x plus 5 and x plus 1. And then the bottom, what multiplies to -3 and adds up to -2? So that would be -3 and a positive 1. So x minus 3 and x plus 1. Okay, and now we're just going to cancel any common factors, top and bottom. Okay, so we notice right off the bat we have x minus 3 on the top and the bottom, x plus 1, top and the bottom, x plus 5 on the top and on the bottom. Okay, so that means the only thing left is x minus 2 over x plus 4. And that's it. That's all we can do there. Okay, that would be our final answer. Don't try to reduce the 2 and the 4. Don't try to cross out the x's. We cannot. These are not factors. Right? The x's are not factors in order to do that. They're attached with plus and minus signs. Same thing with the 2 and the 4. Okay, so final answer, x minus 2 over x plus 4. Let's take a look at our number 6. So elimination would probably be the easier of the two, but you can do this with substitution as well. Let's see if we could maybe do both of them. So I'll show you. Let's do the elimination first. So if I see my two equations, if I can multiply the bottom one by -2, that'll give me a -4x, and then I can cancel with the positive 4x. Okay, so that means I'm just going to rewrite the top, 4x minus 3y equals 27. Now the bottom, remember to distribute a -2 to everything. So -4x, -2 times 5, -10y, and -2 times 7 is -14. Okay, now we're going to add straight down. So 4x and minus 4x, they cancel. 3y, negative 3y, and negative 10y, adding, that gives us negative 13y. 27 plus negative 14, that's just positive 13. Okay, and we just divide now by negative 13. So we have y equals negative 1. Okay, take the negative 1, plug it into either equation. I'm going to plug into the top equation to get the x. Okay, so I'll have 4x minus 3, plug in the negative 1, equals 27. So I have 4x plus 3, right? Negative times negative is positive. And then minus the 3 both sides. We have 4x equals 24. Divide by 4. So x equals 6. Okay, so we have 6, negative 1 as our solution. Okay, let's see how this works with substitution. With substitution, what you want to do is take a look at the simplest looking variable, maybe the variable with the smallest coefficient in front. Okay, so what I could do is take a look at that 2x on the bottom, and I could try to solve for that x. So let's do that. So if I solve for the x here, I'm going to minus the 5y to both sides. So I have 2x equals 7 minus 5y. And then we'll just divide by 2. So I have x equals 7 minus 5y all over 2. Okay, so now that becomes my equation, which I will use to plug in to my x in my other equation. Right? So my other equation is the top equation. I'm going to replace x with what's here. Right? Because this is what x is equal to now. Okay, so let's do that. So we have 4. We're rewriting the top equation. 4, parenthesis, plug in what my x is. 7. There's my substitution now. Minus 3y equals 27. Now I can cross cancel with my 2 and my 4. Okay, so that actually gets rid of the denominator, which is good. So I have 2, parentheses, 7 minus 5y minus 3y equals 27. Okay, and now we distribute, right? Distribute the 2. So 14 minus 10y minus 3y equals 27. Okay, combine like terms. I have a minus 10y and a minus 3y. So that gives me 14 minus 13y equals 27. Okay, I can subtract 14 from both sides. So that leaves me with negative 13y equals 13, right? 27 minus 14 is 13. Divide by negative 13. So y equals negative 1. So y equals negative 1. That means now I could go back and plug it into x. Okay, so remember the x formula. We could just use what we had here when we solved for x. So x equals 7 minus 5. 7 minus 5y. Now replace the y with negative 1. And it's all over 2. Okay, so now just simplify that. 7, negative 1 times negative 5 is a plus 5. Okay, so 7 plus 5, which is 12. And 12 over 2 reduced to 6. So x equals 6. So 6 comma negative 1 is our solution. Okay, so you should get the same thing either way. It's just a matter of which one you prefer. Okay, let's take a look at number 7. Simplifying. So here we're going to be trying to rationalize the denominator in a way, right? Because I is like a square root of negative 1. So remember that I is the square root of negative 1. Anytime we get an I squared is equal to negative 1. So we're just going to replace I squared with negative 1. Okay, but the key thing is what we did earlier. We're going to multiply by the conjugate, right? By the conjugate of 1 minus I. Same two terms, but opposite sign. Okay, so we're going to be multiplying by 1 plus I. Okay, it's a FOIL for both top and bottom. So 3 times 1 is 3. 3 times I is 3I. Negative 4I times 1, negative 4I. And negative 4I times I is negative 4I squared. Okay, the bottom, it's like a squared minus b squared. 1 times 1 is 1 minus I times I is I squared. Okay, now we can just combine like terms. Any I squareds we have, we replace it with negative 1. Okay, so 3 plus 3I and a minus 4I is a minus I. And then minus 4, and replace I squared with negative 1. Same thing in the bottom, replace I squared with negative 1. Okay, now we'll just simplify a little bit more. We have 3 minus I. Negative 4 times negative 1 is a positive 4. 1 minus negative 1 is a positive 2. 3 plus 4 is 7. We combine those. Right? 7 minus I over 2. Okay, so you have an option of leaving it like that, or you could take the 7 and the I, separate it into two fractions. Okay, so you could have 7 over 2 minus I over 2. Okay, so either way will work. All right, let's take a look at number 8. Here we are adding and subtracting with rational expressions. So we need a common denominator, right? We must find a common denominator in order to continue. Okay, so the first thing we'll do is any denominators that need factoring, we need to factor. Okay, so we have 2 over y plus 3. We'll keep it the same way. Plus y plus 15 over y squared minus 9. That's a difference of squares. So y plus 3, y minus 3. So we factored it. Okay, and then we have minus 2 times 2 over y minus 3. So it looks like for this problem, our common denominator will be y plus 3 times y minus 3. Right? That would be our LCD. Right? LCD, y plus 3 times y minus 3. Okay, so that means what we'll end up doing is multiplying the fraction on the left with y minus 3. the fraction on the right will multiply by y plus 3. And the fraction in the middle will stay the same because that already has the common denominator. So y plus 3. Okay, so we're going to go through, distribute. We have a common denominator, which we can just merge all three of them together. Okay, so we have 2 times y minus 3. So we'll have 2y minus 6. We have the plus y plus 15. Now this, be careful, this is like a negative 2. That can get tricky. Negative 2 times y, negative 2y, and negative 2 times 3 is negative 6. Okay, one big fraction bar, and then we have y plus 3, and then times y minus 3. Okay, now we combine. Right, we have 2y and a minus 2y. We cancel those. So we're just left with y. A negative 6 and a negative 6, that's negative 12. Positive 15 minus 12 is a plus 3. And then on the bottom we have y plus 3, y minus 3. And then this one actually has one additional step. Be on the lookout for this sometimes. You see the y plus 3, and we have a y plus 3 on the bottom. Okay, so picture those as factors. You could cancel them out. Okay, so when we cancel out on the top, we leave behind the 1. And on the bottom, we just have left the y minus 3. Okay, so that'll be our final answer. 1 over y minus 3. Okay, so we'll continue with the next part of this in our next video. Okay, that's it for now. We'll see you soon.